Welcome to Leetcode JavaScript, a channel where we solve every single Leetcode question using JavaScript. Today we have the daily challenge problem, which is 645 set mismatch. It is an easy question, however it's quite a tricky easy question. This is in no way complicated or complex, but it's quite tricky, which may annoy many people. You see the ratio of accepted to submissions. Maybe around 40% are accepted, something that's characteristic of a hard problem even. But again, it's quite tricky and I would actually blame the examples for that. But let's go right into it. You have a set of integers which originally contains all the numbers from I to n. Unfortunately, due to some error, one of the numbers got duplicated to another number in the set, which results in repetition of one number and loss of another number. You're given an integer array nums representing the data status of this set after the error. And what we want to find is the number that occurs twice, as well as the number that's missing, and we return it in the form of an array. Now, if you look at the examples, for example here, 1, 2, 2, 4, we can clearly realize, hey, we're missing 3 and 2 occurs twice, so we just return it. Again, here 1, 1, we're missing 2, and 2 is repeated twice. So far, so good. This might be a bit misleading because you would think the sets are always going to be in order, but sets are not necessarily always in order in general, and here's also the case. So actually the set could be in any order, which is something you want to consider because you may think a very straightforward solution is to just look at the indexes whenever something is repeated. That would be so easy, but again, this is not necessarily in order, and we don't really want to sort it. And why don't we want to sort it? Because sorting has a time complexity of O(n) log of n, which is usually not great. Sometimes it's okay to use, but generally we want to avoid it if we can. Something that may come to your mind is using a hash table, which is a fine solution because you want to count what comes twice and then figure out what you're missing. And that can work fine. However, I want to propose to you a simpler and more clever solution. Okay, so let's go right to implementation, and we're gonna start with declaring an answer. Our answer is gonna be an array, and I'm just gonna initialize it to -1, -1. So far, so good. And we're gonna use a for each loop here of each n of numbers. And now we're gonna do something that may look a little bit weird, but I'll explain it. I believe it's a relatively clever way to find out whether something is repeated, and we check it this way. Okay, if this condition occurs, we say that the number that we have is gonna be the ones that's repeated. Now, what does the mat.abs function do? It gives us the absolute value of a number. Say you have -5. If that's the case, it's gonna spit out 5. If you have 5, it's also gonna be equal to 5. So essentially, it's gonna get rid of the negative sign if it's there. Now, else, we're gonna do nums abs n -1 times equals -1. So what we're doing here is flipping the sign of every single position of the numbers. Although the numbers may not be in the position, we can flip the sign and decide, hey, we're just gonna flip every single sign once, and whenever we reach a position that has been flipped already, this if statement is going to trigger, and we can know for sure the number corresponding to that position. We're assuming it's sorted, although it's not. It doesn't really matter because we're treating the numbers themselves as if they were indexes. That number is going to be the one that's repeated. Okay, but now we need to find what number we're missing. So now we need to look through the array once again. In this case, we're not going to use the for each loop. We're going to use indexes because we are interested in the indexes themselves. A plus plus. All right. So if nums I is less than 0, sorry, it's greater than 0, and 1, it's going to be equal to I plus 1. So in this case, the number that was flipped twice, it's going to be the number that's missing. And in this case, again, we take the index itself as being corresponding to the number, because we're not concerned with the number that's going to be in that index, but the index itself. And we can simply return ends after this. Now let's run the code. And it's accepted for the sample solution, or sample example rather. And there we go. This is accepted. It's quite an optimal solution. The spice and time complexity of this are actually quite good. This time complexity is of n, and the space complexity is of 1, because we don't use any additional space. You may think, hey, how about this array? Well, this array is the answer itself, so it does not count towards space complexity. Well, thank you very much for watching, and don't forget to like and subscribe.